This is section 5.2.1, and we're going to take a look at polynomial long division. And so in this lesson, we're going to divide a polynomial using this thing called polynomial long division. So we're setting the stage just a little bit because we are used to polynomials that are already factored, and we're able to get information from it. But let's just say we have a polynomial that's not factored, like this x cubed plus 4x squared minus 5x minus 14. And what if I wanted to find the zeros? Well, we would take our function and set it equal to 0, as typical, but we don't have any of the factoring techniques that we need. Now, if we graph it, and we put this on a graph, we could look at the zeros on the graph. Okay, I got a 0 here, I got a 0 here, I got a 0 here. And so that can be useful, but what if I don't have a graph? Right? So if I don't have a graphing calculator to do it, how could I be able to solve this? Well, the answer is polynomial division. Now, what we haven't really realized is when we factor a polynomial, or even something quadratic, or let's just say if I wanted you to factor 20, and I said, give me a factor, and you're probably thinking, divide by 2, or by 10, or like 2 and 10, right? But the reality is, how did you get the 2 and 10? Well, you did 20 divided by 2, and that gave me 10. So I could say 2 times 10 equals 20. We use division as a tool to factor it. Now that's very important. We use division as a tool to factor it. So looking at algebra 2, if I wanted to divide that by x minus 2, like I'm just going to give us the whole picture, like there are steps in between, we would go through this process. This is the polynomial division I'm talking about. We're going to be looking at this. Now, if I divide, right, this or this divided by this x minus 2, I get this at top. Now, what that means is I can write it as a factor. I can write it as this times this. Well, notice, ta-da, I can find a 0 now, right? One of my zeros is 2. So we use division, I'm going to say that again, we use division as a tool. So with a basic definition, and we don't really necessarily, we do want to get this down, so we're going to highlight this. I know it's not in blue, but we want to get this down. But the idea here is that with this polynomial, when we factor it, we're able to write it as a factor, essentially. That's when we divide it, we can write it as a factor. That's all that it's saying. So it's saying that if you were to divide a polynomial, we have two dx and p of x, and they're non-zero polynomials, where the degree of p is greater or equal to the degree of d, right? So this is greater than this. There exist two unique polynomials, q of x and r of x, such that we could write it as a series of multiplication. So going to this previous problem, what it's saying is if I have d of x and p of x, so here's my p of x, here is my d of x. If I were to go through and divide them, I could write it as two unique polynomials, d of x times q of x. So here's the d of x, but I have this new polynomial q of x, and then I have my plus remainder, and we call that r of x. Well, in this instance, my remainder was 0, which is the reason why my r of x is going to be 0. There was nothing there. But the remainder being 0 is good for us because what that tells us is that it divides evenly. That's what we want to know. So how do I go through and actually divide this polynomial? Okay, I have some steps listed here. The biggest that we need to know is divide, distribute, subtract. If we know those three words, divide, distribute, subtract, basically we're going to be able to do it. So we set up the problem. Right? So I'm dividing by this. This is polynomial long division. And so what you're going to do is you're going to divide the first term with the first term. So I can write that off to the side if it's hard for us to do it in our head. So x cubed divided by x, we get x squared. Very simple. Then we distribute. So I want to distribute this term with both of those terms there. Now, when you multiply and distribute that, you're going to write it under the correct terms. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. I put them under the correct terms. Then the last is subtract. So we have this minus sign. We take that and we distribute the minus sign, so that becomes a negative, that becomes a positive. X cubed minus x cubed is 0. The 2x squared and the 3x squared become 5x squared. And then we bring down the rest. So I'm going to bring down that. And if we wanted to, we can also bring down that. So then we just repeat the process again. This is my leading term. This canceled out. It's 0. It's gone. And so we start all over again. Divide. So the two leading terms, 5x squared over x. That simplifies into 5x. We distribute. So now I'm going to distribute that 5x with those terms. So 5x times x squared is 5x squared. 5x times negative 3 is negative 15x. Now we're going to subtract. Distribute the negative. So negative and a positive. And so 5x squared minus 5x squared cancels out. And then negative 13x plus 15x is 2x. We bring down the next. And we repeat the process again. Divide. X goes into 2x. Write it out if you need to. So I get 2. Then we distribute. So 2 times x is 2x. 2 times negative 3 is negative 6. And then subtract. Distribute that negative. So that's a negative and that becomes a positive. Everything cancels out. I get remainder 0. So this is going to be my answer. Now, if you had a remainder, we're gonna see that in another problem, but you're gonna add the remainder at the end. But that's essentially it. Divide, distribute, subtract. Divide, distribute, subtract, etc., etc. Let's look at another one. So if I wanted to set this up, x cubed minus x squared plus 1. Now, we didn't have to do it in the previous problem, but you notice that in this, I have minus 5, or x to the 5th, but there's no x to the 4th. We have to put placeholders when we divide. You have to put placeholders when you divide. If you don't put placeholders, you may divide and then you have no place to put it. So if you look at that previous problem, right, I was able to line up the cubes, I was able to line up the squares, I was able to line up the x's. Well, if you don't put placeholders, you might divide and then there's no place to put it. And so that's why you need the placeholder. So now you have some place to put it. So going through the steps, remember, divide, distribute, subtract. So the first step is divide. We divide those terms. So negative x to the 5th over x cubed. If I reduce that, that gives me negative x squared. Now I distribute. So I'm going to distribute this with all three terms. So negative x squared times x to the 3rd is negative x to the 5th. Negative x squared times negative x is, aha, see? This is the reason why I put that placeholder, because now I have a place to put it. And then negative x squared minus x is negative x squared. Now subtract. So distribute that negative. So that turns positive, that turns negative, that turns positive. So that cancels out. Minus x to the 4th. Bring that down. Bring that down, bring that down, and I still have the plus 0. Now we do it again. Divide. So divide the leading terms here. So negative x to the 4th over x cubed. That gives me minus x. Now I need to distribute. So I'm going to erase these distributing lines to make it a little easier to see. So distribute. So negative x times x, so negative x times x cubed is going to give me negative x to the 4th. Negative x times negative x squared is going to give me negative x to the 3rd. Sorry, positive x to the 3rd. And then negative x times 1 is going to give me negative x. Subtract. So distribute. So that turns positive, that turns negative, that turns positive. That cancels out, and you know you did it right if those cancel out. 6x to the third, that brings down, that cancels out, and we bring that down. Now you repeat again. Divide, distribute, subtract. So divide, x cubed goes into 6x cubed, 6 times, so 6 times, so plus 6. Now I go through and I distribute. So the 6 goes to those. So x cubed times 6 is 6x cubed. 6 times negative x squared is negative 6x squared. And 6 times 1 is 6. Subtract. So I want to distribute. So now I'm going to get 0, since that's now a positive and that's a negative. So that's going to be 7x squared and then minus 6. Now it doesn't divide anymore, right? If I were to divide those, 7x squared over x cubed, I have an x in the bottom. Okay, it doesn't divide evenly anymore. So this is my remainder. So we're going to say plus my remainder over what I divided by. Now I know that this right here is not a factor of my polynomial because it didn't divide evenly, right? So I want my remainder to be 0 if I want it to be a factor. So just something to think about. If you want to practice this problem and check your answer, you can. And so you're going to get a remainder of negative 8. So plus negative 8 over x minus 2, or you can say minus 8 over x minus 2. So what did we learn today? We talked about polynomial division, and we used long division to be able to divide our polynomial. Now, the pattern to remember is divide, distribute, subtract. This does conclude our lesson. If you have any other questions, please leave them in the comments.